Welcome friends. So last time we have seen the influence line diagrams for reactions at support A and B. Now let's continue the same problem. So we have constructed ILD for RA, ILD for MA and ILD for RB. Now the given beam is a compound beam. This type of beam, when it includes internal hinge, two beams are connected together at the internal hinge C. So such a beam is a compound type of beam. Now let's construct influence line diagram for S11, M11, S22, M22. Now two sections are given, section 11, section 22, and we have to construct shear force and bending moment diagrams at these two sections. Now see, just if you are able to draw free body diagrams, or if you understand the concept of free body diagrams, then you will come to know the given section is within simply supported portion or within a cantilever portion. Now here, if you draw the free body diagram, so this AC will act as a cantilever, act like a cantilever beam. Means your section 11 is within the cantilever portion, and the CB, if we draw the free body diagram for portion CB, so it will lie simply supported. So section 22 is within simply supported, and you know the nature of ILDs for the shear force and bending moment for section within simply supported and for section within cantilever beam. And then we have to extend this up to the end of beams according to the Muller-Breslau's principle. So while plotting the ILD by using Muller-Breslau's principle, just introduce a unit displacement in the direction of structural function for which the influence line diagram is to be constructed, and then plot the deflected shape by maintaining the compatibility and continuity of the structure. The deflected shape itself represents the influence line diagram for that structural function. Now with this concept of Muller-Breslau's principle, let's draw ILD for S11. Let us draw ILD for S11. So S11 is within cantilever. We know that for cantilever portion, for this, the left hand will not be disturbed because this is fixed, and total shearing is unit. So you continue up to the hinge. So this is ILD for cantilever portion. When the section lies within the cantilever portion, the influence line diagram can be constructed like this. Now at the internal hinge here, the beam gets rotated and finally the deflection is 0. So this is 1. This is positive. This is ILD for shear force at section 11. Let's consider ILD for bending moment at section 11. Say this is M11. Again, the section 11 is within the cantilever portion. That means we have to introduce a hinge here. We have to release the bending moment, and since this is fixed, will not be disturbed, so only unit rotation is to be taken here. So this is rotation is unit. For this unit rotation, what is the base? Is 4, height must be 4. Base is 4, height must be 4, and finally deflection here it is 0. So join this. So this is ILD for M11, ILD for bending moment at section 11. Next, let's consider ILD for, now let's come to the section 22. Say S22, shear force at section 22. Now shear force, the section 22 is within the simply supported, and shear force you know for simply supported beam, it is like this, and total this displacement is 1. total sharing is 1. And remember, here there is a hinge, so this gets rotated. Since this is fixed, so this part will not be disturbed, will not be deflected. Now therefore, and since section is at center, so we will get this as 0.5, this as 0.5. So this is S22, that's all. The ILD for S22. Now last, let's draw ILD for M22. ILD for M22. Now for this is again within simply supported, we have to rotate this unit rotation, and this is, so this we know the theta 1, if this is theta 1, theta 2, this theta 1 plus theta 2 equal to 1. That means this ordinate will be AB by L. So 2 into 2 divided by L is 4. So this becomes 1. So this is AB divided by L. So this ordinate is 1 automatically. So this also you get 1. So this is ILD for M22. Now that means if you know the Muller-Breslau principle, so we can construct any ILD within the minute. So for at least for determinate structures, construction of influence line diagrams is very simple if you know the Muller-Breslau principle. Now let's consider few more problems, few more typical problems we'll see for beams. And once remember how to use this ILD, say once you know the Muller, this influence line diagram, and then we will see the position of external loading or maximum value of that structural function, and then we'll find out the maximum structural quantity. Let's consider one more problem. Say this is also very standard problem from exam point of view, and the hinge may be given within so this is the internal hinge, and say all these are statically determinate. So this beam is a statically determinate. Suppose this is 10 meter and this is say 4 meter and say this is 3 meter. Say A, B, C, and D, at D internal hinge is given. At D internal hinge is given. So what are the possible ILDs that we can draw? Say RA, RB, RC. Then various sections available are say section 1-1 at a distance 6 meter. Say this is 4 meter. Then you may have a section say here 2-2. Say this is 2 meter, 2 meter. Or say you may have a section within CD also. So CD means again that becomes simply supported. Say ABD, up to ABD beam will be a overhang beam. So that means section 1 is within simply supported beam and section 2 is within cantilever. If you take section within CD or DC, that will be again a simply supported beam, that becomes simply supported. Or say just we will construct here, you take a section say 3 here, and I will take this as 1.5 meter, any distance you can take, doesn't matter. So let's construct the ILDs, because this is very simple by using Muller-Breslau principle. Say let's first RA, ILD for RA, ILD for RA. Now RA means lift A through 1 unit. Lift A through unit, this is 1. And deflection here is 0. So draw a straight line up to the hinge. So this hinge will go down. Again, here deflection is 0. So join this. So this internal hinge, the members are allowed to rotate at internal hinge, that is not external support. So this is plus, this is minus. And this ordinate will be this 4 divided by 10, so this is 0.4. So ILE for RA is over. Next, let's draw ILE for RB. So ILE for RB. So RB is lifted off, means this will up to straight line. So this is one straight line up to the hinge. Keep straight line up to the hinge. So this 0 deflection up to the hinge will lift off here, again gets rotated, 0 deflection here, and so this is plus. And this will be 1.4, this ordinate by similar triangle, 1.4. This is ILE for RB. Then you can construct ILE for RC. So lift RC through 1. But this is simply, say this is plus, here it gets rotated because here deflection should be 0, here deflection should be 0, and ABD is a 1 bar, straight, rigid bar. And then this is the second bar. They are connected by internal hinge at D. So only this much diagram you will get for reaction at C. Okay. The next, see, let's consider for MB also we can now construct. Let's consider MB because there is a bending moment at B. So MB means we have to introduce hinge here, but deflection here is 0, deflection here is 0. So again you will get, this is MB, bending moment, and this ordinate is 4 because its base is 4. Ordinate is also 4, and this rotation is unit is here. Rotation unit is here. So the ILE for bending moment at B. Now RA, RB, RC and moment at B we have constructed influence line diagrams. Now let's consider these 3 sections and draw DMDs. Draw ILDs, influence line diagrams. So only let's first of all learn the construction of influence line diagrams. How to use them, that we will see later on. So this is a S11, shear force at 1, S11. Now S11 means we have to take cut section here. This is within simply supported, so you will get diagram this way. So from here to hinge, here deflection 0, continue up to the hinge, internal hinge. Again deflection here it is 0, and deflection here there is a support, deflection is 0, and the total is 1. Sharing is 1. But we know this is A by L, means this will be 0.6, this will be 0.4. And then this is 4 divided by 10, again you will get 0.4. This is minus, plus, minus. This is the ILD for shear force at section 1, 1. Then ILD for bending moment at section 1, 1. Say M1, 1. Say here we have to introduce a hinge. So we have to rotate this. This is section within simply supported beam. So this is a simply support. Now you continue this thread up to the hinge, and then it gets rotated. So this is plus and this is minus. This ordinate AB by L, that is 6 into 4 divided by 10, it is 2.4. This is 2.4. And from similar triangle, you find out if suppose this is Y divided by 2.4 equal to this height divided by this height, this base 4 divided by 4. So 2.4. This is also 2.4. Okay. Now this is ILD for M11. Now let's come to S22. S22. So S22, that is section is within cantilever portion. So only this is the, say this is 1. So this is also 1 and here it is 0. So this is plus. This is shear force at section 2, 2. Now bending moment at section 2, 2. That is M2, 2. So we have to introduce hinge here, and for bending moment for a cantilever section, and then 0 here. Say this is 2, this should be 2. Height is 2, height of this triangle, and this is negative. So very easily we can construct the influence line diagram once you understand properly the Muller-Breslau principle. Now for compound beams also we can construct. Now the last section, that is section 3, 3. Say this is within simply supported. So for S22, sorry, this is S33. So your diagram will be like this. This is central section, 0.5, 0.5 minus plus, and further will not be continued. So that is the only diagram. And for moment, again, what will be the diagram? Only this much. So this is minus, this is 2, height is 2, this is 1. This is 3, 3. Because we need deflection here 0, deflection here 0, and internal hinge is there. So up to hinge there is one rigid bar, it should remain, so it will not be disturbed. That means whenever there is a loading on left of D, shear force and bending moment at section 3, 3 will be always 0. So this shear force and bending moment will occur only when load is on CD. Okay. Now these are the influence line diagrams. Now we will consider one more problem, and then I will give you a few problems for practice, or 1 or 2 problems for practice. So let's consider a balanced cantilever beam. Say this is 12 meter, say this is 4 meter, say this is 10 meter, 4 meter, and this is 12 meter. So this beam is called a balanced cantilever beam. This is A, B, C, D, E, F. A, B, C, D, E, F is called a balanced cantilever because ABC is overhang beam, D, E, F is again second overhang beam connected at internal hinge at C and D by a beam CD. Means there are three beams connected to each other by internal hinge at C and D. So such a beam is called balanced cantilever beam. This is balanced cantilever beam. Let us construct, say this is RA, RB, RE and RF. So now what are the possible ILDs? There are many possible ILDs. Say let's construct for RA, RB, then RA, RF will repeat like RA, RB from other end. Then let's construct for MB. Let's take section 1, 1, S11, M1, 1. So I will take section 1, 1 say here. So this is 1, 1, and this, say this is 4 meter and this is 8 meter, location of section. Then you take section here, say 6 meter and 4 meter. One more section we can take, say here, at a distance 1 meter and 3 meter. So this is section 2, section 3. Similarly, you can consider a section within DE, section within EF, then reaction RE, reaction RF, then moment at E. So many ILDs are possible. But if you are able to construct ILDs for this, then the ILDs for that part can be repeated in a similar way. So let's draw ILD for reactions first. Say RA. Now I will consider ILD for RA. Now, so lift RA to 1. So this is 1. Then here deflection 0. So join these two by a straight line and continue up to the internal hinge here. Again, the internal hinge is here, but there is a deflection, no deflection here, no deflection here, and DEF is one rigid bar, so it will remain straight, so it gets rotated at the internal hinge. So this is 1. Now let's find out this ordinate by similar triangle. This is plus, this is minus. Say y divided by 1, so this 4 divided by 12. So ordinate is 4 by 12, 1/3. This ordinate is 1/3. So 4 by 12. Now this ILD for RA is over. ILD for RA is over. Next, let's consider next RB, ILD for RB. RB means here it is 1. So that means continue up to the hinge, then next hinge is here. So this ordinate we have to find out. Given ordinate unit is here. Unit is here. So for RB is positive. Now whatever is the loading RB will be always positive. So this now this y divided by 1 equal to this 16 divided by 8. So 2, this ordinate will be 2. So y divided by 1 divided by base of this 16 divided by base 12. No, this is 16 by 12, not 8. So this is 4 by 3. This ordinate is 4 by 3. Now, next MB. Next is say M11, S22, M22, S33, M33. So these ILDs we have to complete. Now next, say ILD for MB. So ILD for MB will be negative. MB. So MB means here, but there is a deflection 0, there is a deflection 0, this should be straight, only you will get negative, and then up to the hinge it will get rotated. So further remains straight, this is minus, base is 4, height is 4, this is MB. So ILD for MB. Next, S11, M11. Next let's complete ILDs for S11, M11. See where is S11, M11? Within simply supported V. So that means ILDs are very simple. Say S11. So simply support this section. Let's take here, transfer here. So shear force means it is like this. So we have to continue up to the hinge. and then it will again up to the hinge here. So this is minus, this is plus, this is minus. This is A is 4 divided by L, 12, 1/3. This is 1/3, this will be 2/3. So total sum is 1. So this is IID for shear force at section 1-1. Then the IID for M11 you complete. Say M11, IID for M11. So bending moment we know for simply supported beam and continue up to the hinge, again up to the hinge. Okay, this is minus, this is plus, this is AB by L. A is 4, 8 divided by 12. So 8 by 3. This ordinate is 8 by 3. And you find out by similar triangle y divided by 8 by 3 equal to this height divided by this height. Now base is 4 divided by, now this base is 8. So this will be y is 8 divided by 6 . That means 4 by 3. This ordinate is 4 by 3. By similar triangle you find out ordinates. Now this IIDs, next remaining IIDs are S22, M22, S33, M33. Let's complete the remaining IIDs. So again you just transfer this lines below. Okay, next S22. Let's consider ILD for S22 is within cantilever. You know this is ILD. For cantilever, this is 1, positive, and so that's all. This is the ILD for S22. Now M22 next. Say M22. Now M22 is within cantilever again, and for cantilevers we know this is ILD, base is 3, height is 3. So this is ILD for M22. In the last two ILDs, say S33, this section is within simply supported . No. So ILD will be this much only. So this is 0.6, this is 0.4. So this is ILD for S33, that's all. And the last one, M33, that is, this is ILD for M33. And this is AB by L, L is 10, so this will be 2.4. This will be 2.4, this is minus, plus, this is plus. So we have constructed all possible ILDs for a balanced cantilever B. Then I will give you one problem for practice. Only one problem, you complete the ILDs. So next problem you take down for your practice. And then during the second lecture we will see the ILDs for trusses. So now you take down one problem and you complete the ILDs. Say you take fixed here, then internal hinge, then you take support,
Then you take another hinge